Yeah. 2 minutes. All right. Welcome again. Yes, it's difficult. See, if you've never given a talk before, when you stand over here, you're very nervous, and you try to, I don't know, invent a way to not be nervous, right? So, and this is what I'm doing right now. I'm just making stuff up. So now it's really difficult. It's really hard. It doesn't go away.
There's a clicker here. Don't you use it?
No, no, no. No, it's okay. Thanks. Yeah. I was telling my friend this yesterday, and he told me Messi, the football player, I'm not into football, but he told me apparently Messi, up to this day, he throws up every time before a match, which is very strange. I mean, the best player of all time, and he still does it. So, goes to show you. I'm not saying I'm Messi, but I do throw up before every talk, so. So. Yes.
Yeah, can you make sure to speak a bit louder because I have trouble hearing from the speaker?
I will try. I will try, yeah. I don't think the microphone is connected to anything. So I will try. I will try. And if I forget, just wave, whatever, right? So, can the people in the back hear me? All right. All right. Then I think there's kind of a seat over here. I'm not sure if it's we have a free seat over here. I know we don't want to sit over here, but I don't blame you. I don't blame you. Oh, that's really. I can start. I will wait for this gentleman. Yes. All right. So, yeah, okay, welcome, I guess, again. My name is Mahmoud Abdelghani, which none of you will be able to pronounce, but still. And I will try to convince you, fine people, that Java is an interesting language to develop games in. And if nothing else, I will change your mind about some things. But like I said before, I didn't expect so many of you to do Java, right? So that's really, for me personally, it's a little bit disappointing, but fine for you guys, right? You do enterprise Java, most of you, right? Okay. All right, I do enterprise Java as well, and as you will be able to tell, I'm a big fan. So let's see. All right, so and also like I just mentioned. This is for the benefit of the people who are not watching at home, right? But like I just mentioned, I really have a difficult time starting a talk, right? It's just difficult. How do you start, right? And I used to make fun of people, you know, when you always have those talks and the first couple of slides are about your hobbies and whatever and how many cats you have and that kind of stuff. But till you give a talk, and when you give a talk, you kind of understand because how do you start a talk, right? This is a room full of people. You don't know the people, you don't know their interests. So how do you start a talk? So, introduction, right? So yeah, all right. So okay, again. So background, of course, like I said in the description, which I think nobody read, but the description, right? The reason I'm doing this is because I'm porting Doom 3 to Java, right? And I learn a lot of stuff. So this is okay. I don't know. I'll just go through this, right? Most of my slides are like this, actually, so it's kind of boring, but we'll see. All right, so Doom 3, right? So that's the name of my project, right? Because we are excellent at naming stuff, right? I don't know. And like I say here, it's a temporary name. I just, you know, you need to create a new project, so what do you call it? Yeah, Doom 3, right? At first I thought I would call it Doom 3J, right? Like 4J, like everything in Java, like log4j, whatever, 4J, but 3J. But then I named it this and whatever, right? It's up on GitHub. You can check the codes, and I don't know why. So this is the question everybody seems to ask me. So why are you doing this, right? And the honest answer, and most people find this answer very amusing, but it's not meant to be amusing, is that I don't remember. Thank you. Yes, but it's honestly not meant to be amusing. Like I said, it's just I honestly don't remember. I started it at 5 years ago, kind of, right? Sorry, but I don't remember why I started it. To be honest, right? I have some ideas about why I started it, but I don't remember the exact reason I started, right? But as far as I can remember, right? So 5 years ago, I had the Doom 3 source code on my hard drive, and it was just there. That's it. I started reading it, and I thought, I think this is how it went. It probably didn't go like this, but you know, I thought, hey, this is a cool project. And what I just mentioned 5 years ago, right? At the time, this I do remember. At the time, I thought I would be done in 6 months. I thought, no, seriously. I thought 6 months I would be able. I would be done. One thing, and the other thing is I would be the Java version would outperform C++ version, right? So yes, planning, right? So anyways, sorry. So yeah, 5 years, right? So what do I use? I only use core Java, and I only use OpenGL, an OpenGL wrapper and an OpenAL wrapper. That's the same wrapper actually, but whatever. And if you have any questions, remarks, or echoes, whatever, just send me over there, right? Let's see. So my yeah, so I'm not an expert, obviously, right? One time, this is very interesting actually, because in the description usually I say this is a hobby project, right? And one time after a talk, somebody came talking to me that this is an official port of Doom 3 to Java, right? And I'm officially affiliated with id Software, which is not true. I'm not officially affiliated with anybody, except myself. But I'm not an expert. I'm not an expert game developer. I don't actually see myself as a game developer. I'm an expert in Java, which is very important. I'm not an expert in C++. I'm not an expert in a lot of things. I tend to offend a lot of people when I talk about this stuff, so I'm sorry if I offend you. And I hope somebody learns something, least of all, never to come to any of my talks again, right? So yeah, this is just my disclaimer, right? So yeah, like I said, I expected less people here to know what Java is. But this is kind of important to the context of the rest of the talk, right? So what is Java, right? So yeah, some people say it's an interpreted language. Some other people say it's a compiled language. Some other people say it's something else. It's actually something else. It's not really interpretive. It's not really compiled, right? Who doesn't know, actually? I'm just going to explain it very well. Okay, this will come back later. Just ignore this for now, right? So yeah, open source. Java is open source, which isn't actually 100% true, right? So if you go to the Java room here at FOSDEM, it's called Free Java. And if you ever thought why it's called Free Java, it's because not everything in Java is actually open source, which is a very complicated story. And I think most of you know this better than me, because I don't know the exact details of why, right? Some people blame Oracle for this, but this is a problem that existed since Java was Sun, actually. So, but mostly, you know, the biggest part of it is open source, which is also important for the rest, right? Java chose to do signed math, right? So signed and unsigned, right? So unsigned is numbers that don't have a negative component. They are basically positive. So if you have 32 bits, it's 32 bits of positive joy and whatever, right? And Java chose not to do this. And the background story behind this, which is a kind of funny story, is James Gosling, back in the day, he couldn't decide whether to put unsigned math in Java or not. So what he did at Sun, he wrote a lot of equations, unsigned math, in the hallways, right? And he just asked all the engineers at Sun to solve them. And surprisingly enough, not a single one was solved correctly. So he decided it was a bad idea. I disagree with him, but that's he's him and I'm me, right? So that's something else. Java, we use references for everything, which is strange. It's not strange. It is what it is, right? It just is. What is strange is that you have no pointer exceptions when you don't have pointers, right? And the reason this is strange, if you don't know why this is strange actually, is because technically speaking, a reference could never be null. But the way we use references in Java, they can be null, because we use a kind of a hybrid reference. It's something in between a reference and a pointer. It's something weird. That's why it's, reference by value is actually more accurate, right? Yeah, we don't support operator overloading. So yeah, if you've ever tried to write a game engine, a 3D game engine especially, right, without operator overloading, it's very, very annoying. It's very difficult. I remember I talked at FOSDEM, I think last year or something, and somebody mentioned the same thing, and he had this comment, which I love. It's like doing math, he was talking about Go, I think, but doing like this kind of math without operator overloading makes your eyes bleed, right? It's just terrible. It's just terrible. And there's also a lot of stories about why they didn't do that, but we'll not get into this because I stuck with time and my timer isn't working. How much time do I have? How much time do I have?
10 minutes.
People in blue. I've been talking 10 minutes? Seriously? Okay. I've been talking 10 minutes on slide 1 or slide 2, whatever, right? And in Java we have final, which is kind of like const, but it's not really, right? So, yeah. So I'm going to give you this slide. I'm going to skip this one actually, but right. So I love this comment on Stack Overflow. No, it's from Hacker News about why Java kind of sucks, right? And I'm not sure if people can read it in the back, but if you can't, it's amazing. Just trust me. And when other people start to laugh with them. Right? It's just amazing, right? But this is absolutely true, right? There's a lot of a lot of the hate that comes with Java is just like, you know, it's what people are used to doing in Java, right? The way people are used to writing code in Java, like getters and setters, right? Everybody here writes getters and setters. Have you ever thought that that was a retarded idea, right? Because, yes, thank you, because it is, right? You actually don't need it. There is a historical reason for why you needed it like 10, 15 years ago, but people forgot that reason and are still doing it. But we actually don't need them. Right? I'm not talking about something like Project Lombok or whatever. No, you don't actually need them. And when you write getters and setters, you force the JVM to do like an extra optimization step for you, right? Which shouldn't be there anyway, because you're creating like an indirection, right? But whatever, right? But that's like I just love this. Anyways, so I'm kind of like so how many people don't know these terms? Be honest. You're not appearing on the camera anyway, right? Yes, okay. So, yeah, so actually the first slide, you know, talking about Java was kind of like me ranting about all the shit I hate about Java, right? This is actually, so what is Java, right? So Java, because you can call a lot of things Java, but it's kind of inaccurate in times and it's kind of incomplete at other times. So you have the JLS, the Java something something. It's a language specification actually, right? So some people call that Java, right? Because the language specification is completely open source, and if you implement it you can implement it in your own way as long as you produce these results, and we will recognize you as Java, right? So that can be Java. You have the JDK, or the language itself, right? So the actual code you write, which is based on the specification. Some people call that Java. Maybe it is. Other people, and most people actually, or most purists, right? They tend to call this Java actually, right? So the JVM, the Java Virtual Machine, which does garbage collection for you, which does just-in-line compilation for you, which has the Java memory model for you, right? So it's kind of strange what's called Java and whatnot, right? But we'll get to that. So to you, right? Because no, it's just something. So it's just no, it's just. Because I saw you closing your eyes, right? And one time I was giving a talk, right? And I saw a gentleman in the first talk, he was just like snoring, right? Obviously, right? It was after lunch, and people say I have a soothing voice, or boring voice, which is code for boring voice, right? And it just started. But at the end, I gave a demo, and he was just clapping like crazy, like he was awake the whole talk. But whatever, doesn't matter. So I don't blame you. That's my thing, right? A friend of mine gave a talk once. You know, he did it. It was a lightning talk, and he did it like a boxing match, right? So at first, I wanted to structure this talk like a boxing match, the same way, because I like that really, right? Which I didn't in the end, right? But I had made this slide already, and I love this slide, so I just kept this slide, right? But this is the idea, right? So C++ is the reigning king of the game development world, right? Whether you like it or not, whether you admit it or not, right? And I see Java as kind of like a contender, right? It has a lot of good stuff that it can offer. I think it can offer, right? I'm gonna kind of like show it, right? Which again doesn't work very well because most of you do Java, but I'm gonna do it anyway, right? Yeah. Yeah, I was listening to this song while I was. Does anyone know what song this is? Excellent. So I was listening to this song and just wrote it here. So, yeah. Right. So, like I said, this is based on a project I did, right? So the first thing you come across is setting up your environment, right? And I cannot stress enough how much hell it is to set up an environment in C++, right? The reason I'm still using this laptop, which is a 7-year-old laptop, while I have like a couple of months old laptop at home, is because I have set my C++ environment on this laptop, and I don't want to do it again on my other laptop. And I know it sounds stupid, but really, I hate it. I hate it so much, right? But I'm not a full-time C++ developer, so it's probably easier for them. But still, there's so much that can go wrong, right? You have to have the right DLLs, the right version, 32-bit, 64-bit. Set up the linkers. You have a lot of like macro and preprocessor bullshit you have to deal with. It's really hell, right? And this one, right? So this one is actually this comment here, right? So at one point, I upgraded to a different. I have a different laptop with a different version of Visual Studio, which just didn't work, right? Because the project was written in that Visual Studio, and you have to have like the professional version, and I was using the Express version because I'm cheap, right? And it didn't work, right? So it was just hell, right? And these are two guides, and were written. This is for Windows, and this is for Mac OS, right? So it's kind of more detailed, only to get the project running in your IDE. That's the only thing in this guide. And it's a very long guide, right? And it's a lot of work. And yeah, so yeah, money. Does anybody know what sconce is? Yes, thank you. You can come sit over here as well. No, but so sconce is kind of like if you know what make is, it's like a super make. Let's go with that, right? And this is one of the things, it was also included in the project. So it's a Visual Studio project, but they also had like a sconce file, which you can see as a super make file, right? For the Linux build of the game, right? And I want to do some benchmarks for GCC. So I just thought it would be easy to do this, right? To just load the sconce file and compile it. And it wasn't, right? It was really a lot of work. I won't describe it here because I've already ranted about this enough, right? Chromium, yeah, let's not talk about Chromium at all. Suffice it to say, it takes like a day to compile it, but that's a different story. But yeah, so this is C++, right? This is very difficult. It takes a lot of time, right? You have a new developer, you want to set up your environment, you're literally doing it for a day or whatever, right? And it works, sometimes it doesn't, you upgrade, it doesn't, whatever. It's difficult, right? But this is kind of actually what we want, right? And this is kind of what we get in Java. And the reason I say kind of is because, like most of you know, you can fuck this up. Anybody can fuck that. Anybody can make anything as difficult as they want, right? But in the purest sense, you can make it this easy, right? You download an IDE, it has a JDK sometimes, it has Maven sometimes, and that's it. You load in your project and it works, right? Most of the time. But, like I said, you can make anything difficult for everybody. But, yeah, right? So this is kind of like how I see it in Java, right? You have a lot of wizardry stuff, right? Nowadays in IntelliJ, you can just point it to a folder and tell it, okay, load some stuff, and it will figure out how many projects you have, how many dependencies you might have and not have, and that kind of stuff. They're getting good at it, right? And it's mostly open source, right? In the C++ world, everything is closed source, and everything you have to pay for. And sometimes you have to pay a lot of money. A friend of mine wants to use like 3 plugins from a company. It was like one plugin is $5,000, but if you buy all 3, you get them for $10,000, right? And we were very simple algorithmic plugins, right? He could only implement them himself, which he did, right? Because it was cheaper, right? So, but that's the world of C++. It's a different world, right? But not everything is fine, of course, in the world of Java. I mean, paths, right? You have to set up so many paths if you want to run it from command line, which can be shitty. And sometimes 32-bit versus 64-bit can be very annoying, right? Especially if you do native code stuff, like what I do with OpenGL and such. So it's not perfect, of course, but I think it's better than C++, right? How many of you do C++? I didn't ask that, actually. Wow. I feel betrayed, right? It's like the same people also do Java, actually, right? So, but okay. So, all right. Oh, I thought I removed this slide, but okay. So another thing, right? Like I just mentioned, make files, right? How many of you? Okay, let's not keep doing that, right? I actually find it annoying when speakers do that, but I sincerely want to know, which is weird. But if you've never used a make file or any make, so I use the word xmake because there are a lot of variants, cmake and qmake and whatever. But they're essentially mostly the same. And if you've never used them, they're basically just meant for building. Like you can do some testing sometimes, you can have some profiles in there sometimes, depending on, like sconce can do a lot of cool stuff, right? But it's not Maven, right? And if you've never used Maven, which is some of you, right? You can do a lot of cool stuff in Maven, right? So a lot of this stuff you can do also in make files, right? But this one, right? This is the most important one. I think this really makes Maven the best thing ever, right? And that's, yeah. How to explain this? I don't know how to explain this. Does anyone know how to explain this? Does anyone want to explain this? So transitive dependencies especially, right? So when you have a dependency that has a different dependency, right? Usually, if you have a POM file, if you have a Maven file or a make file, one of those cool make files that have dependencies, because most of them don't, you just know what the dependency is, but you don't know what the dependency depends on, right? Maybe sometimes you do, maybe sometimes you don't. Maven deals with this, right? Maven is excellent in this, right? It will get the transitive dependency for you, right? The right version, as long as you adhere to the Maven like strategy, right? And I think this is really, really, really amazing, right? And Java, cool, right? C++ doesn't have this. When I talk to a lot of friends of mine who do full-time C++, they're also amazed that C++ doesn't have this because it's actually kind of a very simple problem to solve. The problem is in C++, everybody's very protective about their own things, right? And nobody wants to communicate or like say, okay, we're going to have one standard or whatever. So, but it's kind of simple. So, but yeah. Ow, ow, ow. Yeah. This was tweeted a couple of days ago. Did anybody see this? So when you see something like this, right, and you've never done C++, you're kind of amazed by it, right? Something takes 48 hours to compile. And with one small optimization, it goes to 4 hours, which is still a lot of time, actually, right? I know TensorFlow is huge, but still, right? So this is something, so this is the part where I talk about where I needed to do some scone stuff to do some benchmarks, right? So at the beginning, right, compiling Doom 3 in C++, right, it took me really like 25 minutes. But the reason I have a question mark is because I don't have Windows 7 anymore, so I can't really reproduce it, so you're just gonna have to trust me, right? So yeah. But yeah, now it takes like 10 minutes, right? You do like a multiprocessor optimizer switch, right? It takes 3.5 minutes with 100% CPU, and this thing has like 8 logical cores, I think, which is a lot, even if it is like a 6-7-year-old machine, right? GCC, okay, kind of the same. I'm not sure, so when I got an error and doing it with O2 optimization, and there's a reason why I did it with O2 optimization, which I'm going to tell you about. But when I got the error, it was like 30 minutes, but then I fixed the error and it took only 12.7 minutes. I'm not sure why. And I'm not good enough in GCC to know why, actually, so let's just leave it at that. And O3 optimization. My code currently, it compiles in like 25 seconds. And like 6-7 seconds of those are like Maven just starting up and doing stuff, doing nothing actually, right? And I think this is amazing. I think that for game development, this is amazing, right? You want to prototype the whole time. I know, so none of these are incremental builds, right? So all these are like clean and builds, right? What it says there, from scratch, right? Oh yeah, and if anybody has any questions or remarks, anytime, just shout, right? I prefer that actually, so not shouting, but I prefer questions like in the middle, right? So any questions? No? Really? You? You have a question. You want to say something. You don't believe this. It's true. Sorry? You're trying what? Oh, you're trying to think of a question. Okay. Next slide, I'm going to come back to you. But this, right? So and I tried so incremental builds are very fast, of course, right? So but incremental Java also has incremental builds, right? So that's why I'm kind of like trying to compare apples to other strange apples, right? This is amazing. I think this is amazing, right? And granted, this doesn't give you an executable, right? So you still, the way Java works, of course, this is like a meta something in between bytecode, really, right? But this is the reason I did the O2 optimization here for the benchmark, right? Because a lot of people they talk about this. So like if you talk to a JVM architect or a JVM compiler engineer or whatever, right? They say actually you shouldn't compare what the JVM does for you with like pure GCC, right? So like O0 optimization, you should compare it to O2. And the reason for this is because at the end of the day, the JVM still jits code for you, right? It does like hotspot optimizations for you when it runs, right? And it's kind of, the only way you can compare it to something is with optimization. So that's why it should be O2. I was kind of disappointed that the difference in time between O0 and O2 was so small, but that's something else. Doesn't matter. So yeah, so in the boxing match thing that I didn't do that I should have done, right? I think Java wins here, right? For me, at least, right? You have a question? Still? You have to have a question, right? So startup times, right? And this is also kind of surprised me, but okay, so not this slide, but the slide after this kind of surprised me. So yeah, I'm trying to compare them, all right? So the game runs. Maybe I'll show the game if enough people want to see it, but at the end, and if we have time, because how long? How much time do I have?
We have half an hour.
Yeah. Okay, all right. So yeah, so I kind of expected this, right? So this is the Java version, this is C++ version, which I should have maybe like labeled or whatever, right? But you're starting up the game, right? So Java should take longer, right? It's per definition. Java cannot start faster than something that is optimized C++, because Java itself has to start, the JVM itself, JVM warm-up time, right? So yeah, so this actually know what JVM warm-up means, but you know that, and you're going to pretend you didn't. So, but yeah, right? So Java version of the game takes like approximately like 9 seconds longer for the JVM itself to start up and do stuff, right? So I expected this, so I'm not really that disappointed in it, to be honest. It is a huge code base, so yeah, it doesn't matter, right? Yeah, I said there pre-warm up with a question mark, right? Because yeah, nowadays you have a lot of techniques actually to like avoid this kind of shit, but I'm not sure if you want that. I mean, it doesn't matter. It's 9 seconds. Who cares, right? So yeah. But this one did surprise me, right? So these are actually loading times. So this is kind of like loading the first level. This is the loading time of the first level. And the Java version was faster. Unfortunately, I don't know why, because I kind of like just made these slides like a couple of days ago, and I was very deadlines and stuff. You enterprise developers know how that goes, right? So I didn't really have enough time to like dig into this and see why actually the Java version was faster, right? It's not much faster, but I expected it to be much slower actually. At least exactly the reverse, right? Because always when I'm starting the game, right, at the end result is always, right, the C++ version runs first, right? So I honestly thought this would be slower, but it's faster. I'm not sure why. So don't ask me that. Oh, you have a question? Yes.
Do you think that they chose just starting up the game, those loading times as what they would use, or which system they would use, or they just automatically assume that C++ was superior?
In what sense?
Just starting up the game took 20 seconds from the C++.
Yeah.
And did they test that and then said they would use the C++ and discard every other type of testing? Or was
Who's they in this conversation? Sorry.
whoever developed Doom 3 for C++?
Can you repeat the question, because the people on the stream cannot hear you in the audience? Please repeat the question that was asked to you.
See, if they're not here, they're not allowed to hear the questions, right? It's your right. No, I'll repeat the question. Sorry, but I'm still trying to understand the exact question. Sorry.
Whoever developed
Hi. 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 Sorry.
Whoever developed the C++
Version, yeah.
port,
Yeah.
did they test the two multiple
That way.
versions?
Okay, so the question is, so first, the clarification, the original game is C++, right? So it's not really a port. So the question is, so the people that did the C++ port of the game, did they compare it to Java, right? That's basically the question. So yeah, so it was originally developed in C++, unfortunately, or fortunately, I don't know, right? And actually, a funny thing about that, actually, so people who do C++ a little bit, if you look into the code of Doom 3, a lot of it looks like C, right? And I know a lot of people don't like to admit that there's a difference between C and C++, but it's like a shitload of structs, for example. They also have classes, but they have like amazing amount of structs, right? And a lot of C paradigms in the game, right? And there is a story that says because this was like the phase that they were starting to learn C++, which is interesting because this was, I think, late 90s till to like 2005. The game took like 5-6 years to develop. And this was the phase they were learning C++ and they didn't like a lot of stuff, so they did it in C, right? Another thing, which, yes, sir?
Now you mentioned C, so what are your opinions? You presented some match between C++ and Java, and now are you talking about C, so I'm curious about your opinion about C versus Java.
Okay, so you're curious about my opinions about C versus Java, right? So that's an interesting question. I like C more than I like C++, but that's something personal, right? It's not really about, I'm not talking about this. You mean from a game development point of view, I assume, right? Yeah, I'm going to touch on this a little bit later, but right now at least, for the purpose of this, C and C++ are kind of the same. They're not the same, I know, right? And I'm looking at you, the one who knows what sconce is, because excellent, right? They're not the same, but for the purposes of this, you can claim that they are the same. And the reason for that is, yeah, I'm going to skip this for now, right? But I'll come back to it later. Sorry. Did that answer your question? Sorry. You have to have another question. Right? So begin preparing for now. And all right. So I don't know why. Like I said, why this is faster, but and this part as well, which is strange, but I will dig into that. But yeah, I was mostly interested in the warm-up time actually, not the loading time itself, right? I wanted in this slide actually I wanted to like demonstrate that C++ was better, but it backfired. So yeah, doesn't matter. Yeah. Actually, when I found this picture online, the first thought that came to my mind is actually, isn't this kind of like child abuse, right? Because if you put your child in this position and you photograph him for like or her for like your own profit and fame and whatever likes on YouTube or some kind of stuff, it's kind of bad actually. But it's a nice picture. That aside, right? So yeah, so multitasking is really difficult, right? So this is something else I wanted really to talk about is like CPU utilization in Java, or what you can do with CPU utilization in Java, what you can do with it in C++, right? Basically, you can do exactly the same things, right? But but Java, it like facilitates a lot of that stuff for you, right? And I think the next slide, or the one after that at least, or something like that, touches on the thing that everybody hates, garbage collection, right? But actually, garbage collection is kind of like married to multi-threading, right? So yeah, threading bonanza, threading is hard. Thread safety is very expensive. I hope everybody knows why. Does anybody know? So thread safety. So the idea of thread safety is that when you make a structure, for example, whatever, like a list, thread safety means that when I access something or I change something in the list, a different thread is not allowed to do something else in that until I'm finished. That's basically it, right? It's actually not that at all, but that's like the hello world example of that, right? So yeah, Java does that very well, right? It facilitates a lot of stuff. It has a lot of like safe and unsafe flavors of structures, right? Like, yeah, what I just explained is kind of like atomicity. I don't know how to pronounce atomicity. You're a native speaker. How do you pronounce this? Yeah. What he said, right? Atomicity. It's like, thanks, man. Right. So basically, the idea here is what I actually want to touch on, because there was a podcast a couple of days ago, Jonathan Blow, right? And he mentioned, yeah, you listened to it, the 3-hour thing. You're laughing, so you must have listened to it, sir. Oh, you've heard of him. Okay, so Jonathan Blow is the developer of Braid and The Witness, right? Pretty cool guy, not a lot of nice ideas. There was a podcast a couple of days ago. It was 3 hours. And he got asked this same question, right? Like multi-threading and whatever. And his answer, and the answer of a lot of game developers, especially the engine developers, is there's actually not a lot of things in a game you can do that requires multi-threading and parallelism and concurrency and that kind of stuff, right? Which might be true, right? Because if he says that, he probably knows that it's this better than me. I have no idea. But my problem with this idea, at least, right, whether it's true or not, is this kind of thing, right? So you have Moore's law.
I think that's right, but only for single-player games.
That you don't require multi-threading in. Yeah, okay, but their comments, or mostly those guys, are in like engine developers, right? So they mean like in graphics engines and that kind of stuff, right? But give me just like 1 minute to explain this, right? So you have Moore's law and you have Amdahl's law, right? Moore's law says something like every like 16, 17 months, I don't remember, somebody will know the correct number of transistors on a CPU thing will double, right? But there's an end of life to that because we can't get any smaller or whatever, right? So at some phase, right, we cannot expand the CPU more than that. And technically speaking, we've actually reached that a long time ago, right? But we changed how we view Moore's law, right? So first we looked like, okay, so what's the maximum speed you can gain from a CPU? And now we turned it into something like, oh, how many cores can you get on a CPU? Which is kind of different. Because how many cores comes back to this story, right? And how fast something gets is this story, actually. And Amdahl's law, which I'm going to screw up, but if somebody can correct me, then please, right? Amdahl's law, it says something like, not all problems can be parallelized. That's kind of like it's not actually what the law says, as far as I remember, but it's kind of like the takeaway that I need here, actually, for this, to prove my point. Let's keep it there. Right? Hello? So, sorry. So that's my problem, right? So, true, not all problems can be parallelized, right? That's what a lot of the engine developers say, right? Let's assume that's true. But if you like, don't think this generation, don't think the next generation, but like 6, 7 generations of graphic engines later, right? You're gonna hit the roof of like, I don't know, a single core of, I don't know, what's the fastest now, 3.5 gigahertz or something? You're gonna hit that. Okay, so you can't parallelize the problem. What then, right? I don't know, right? And yeah, like this thing says, okay, so maybe we'll be better programming again, right? Because we've kind of like unlearned how to optimize stuff. So maybe we'll learn it again. But still, there's only so much you can do because it's not going to expand anymore, right? You're going to hit the roof and that's it, right? So that's why I think this is interesting, right? I'm not saying you need it. I have no idea if you need it. In Doom 3, I don't really need it. I have like 2 threads for the whole game, right? And the second thread, actually, I don't need it, but it was in there in the C++ version, so I did it also in the Java version. But technically, I think they were experimenting with threads as well, actually, so that's why they put it in there. But yeah, do you need it? I have no idea, right? But it's just a question. And if you need it, then Java is actually pretty interesting for you, right? And why? Again, a cool tweet. This one was from like a couple of years ago. Does anybody not know who this is? All right, so I assume none of you know who this is. So this is Tim Sweeney. He's like the guru developer of Unreal and all the Unreal engines or whatever, right? He doesn't do it by himself, but he started once upon a time by himself, right? And there was a discussion, something about the garbage collection, and he said this, right? Lately, the last couple of years, he's been doing a lot of research, I think, about, dude. That's like, okay. So He was doing like research about programming languages and that kind of stuff. And he tweeted this, right? And this is like the first tweet I think I liked or like saved or something like that, right? And I found it a very interesting argument, actually. And I dare say this tweet is actually kind of like what made me do this talk. So if you need somebody to blame, blame him. But this is correct, right? So usually when you have like a big game engine, you have like scripts, right? Because you don't want to hard code everything. So you want AI to be scripted. You want your enemies to be scripted. You have everything to be scripted, right? And when the scripting language gets so complicated or complex, right? You kind of like write an interpreter, your own interpreter, and your own parser for that. And that's what he's talking about, right? So none of the developers that keep crying about garbage collection, right? They actually, you know, they mind this, right? That you have a large overhead of parsing and interpreting these things during runtime, right? And they can be huge. In Doom, they are fucking huge, right? So that's interesting. It has nothing, yeah, it's kind of had something to do with my point, right? So this is actually the part where I wanted to play this video, which we will try in a minute. And if everybody stays quiet, you will hear it, I think. But we will play it now, actually, because I'm running out of time. Let's see. Where's my pointer? No woman. Let's see if it works. Can anybody hear that? Not even the people? All right. Excellent. Okay, so... okay, sorry. But anyways, so that's actually, it's related to this thing, right? Embrace the GC. A lot of people don't understand how the GC works, actually, right? And this guy, I don't remember his name, Brian something. This is actually talk about Rust, right? And he was using as example the GC in JavaScript. And I didn't know the JavaScript was actually garbage collected. That's my fault. But he was using as an example, right? And this example, it just shows that you can have memory leaks in Java and in JavaScript, right? And that completely screws up your GC, right? And that's kind of like, because the reason that's important is kind of like this slide again, right? The spiky 1% for garbage collection, right? Because the whole time, I have 15 minutes left. Thank you very much. The whole time, people only talk about stop the world garbage collection, right? Which shouldn't happen anyway, right? So some of you are the Java developers and know this. If you have a stop the world garbage collection, something is wrong. It's not the norm. It shouldn't happen, right? But that's the only thing the outside world sees, right? And I did some digging, and I didn't know this either, actually, but Unity is garbage collected, right? Unreal has a garbage collector. And there's an awesome talk from GDC about Mortal Kombat. I don't remember which Mortal Kombat. Mortal Kombat has a garbage collection thing. Memory management more, actually, but the garbage collection thing, right? And that's actually the reason I put this thing here, because one of the things garbage collection can solve and you cannot solve, or very difficult for you as a person doing pure C++ solve, is memory fragmentation, right? So let's say you allocate these are 30 bytes, right? A and B are both 10 bytes, right? You free A. Now we have a gap of 10 bytes and a gap of 10 bytes. And you have a new object of 15 bytes. How do you allocate it, right? And this is called memory fragmentation. Garbage collection solves a problem for you. You yourself, if you do it in C++, it is solvable. Everything is solvable, of course, right? But it's a very difficult problem to solve, right? I'm going to skip the rest, kind of, because I'm running out of time. But yeah, not everything is great, of course, in Java, right? Memory footprint, bad. What? Anybody? No? You have a question? No? You, sir. You, sir. Yes.
Have you tried compiling it with Graal VM to a native library?
I have not. So the question is, yes, sorry. The question is, have you tried compiling it with Graal to native code? Ahead of time compilation, that kind of stuff, right? I haven't tried it, to be honest. Currently, so these are problems I'm just trying to like, if I show you the demo at the end, you will see that I have much bigger problems than this, right? These are just kind of like, because I'm saying a lot of bad stuff about C++, which isn't fair, right? Java also has a lot of bad stuff, right? So this is kind of like that. But I haven't tried it, although a lot of people have asked me that, and I'm very curious myself, to be honest. Yes. Any other questions? No. Yes, sir.
You mentioned working with collections and in my experience that
I'm sorry, I really can't hear you.
So you mentioned working with collections.
Collections, yeah?
And do you actually do that in your core? Because what I found is they are quite costly in terms of performance, and I switched everything to it.
So the question is, thank you.
Have you encountered the same problem?
I have encountered the same problem. So the question is, to repeat, do you use Java util collections in the game, right? Because I mentioned that earlier. Because his experience is they're very bad for performance. This is also my experience. They're very bad for performance. This is also the experience of the developers themselves, the C++ version of the game, because they created their own collections. And arrays are much faster. Of course, arrays are much faster. Unfortunately, I could not use an array for everything. But I try to use arrays where I can. And if anybody wants to know more about this, raise your hand now or stay silent forever or something like that. Because this is a Java question, he knows what he's talking, so not everybody might know this. Does anybody want more information about this part? We can talk more about this. No, we can. Trust me, we can. But we cannot? No, we cannot. But anyways, so the memory footprint is just horrible in Java, right? But yeah, if you didn't expect this, then you're kind of deluding yourself, right? Java, and it's kind of, so I think I have another slide on this. Yeah, so CPU overhead is negligible, don't care about that, memory overhead. But it kind of also depends on which kind of GC you use, right? So I don't remember which GC does what, right? But certain GC, garbage GC is for garbage collection. Certain garbage collection algorithms require that you have double the amount of memory, right? Because double the amount of memory you actually need. Because you do something and then you copy the whole thing to the other thing and you copy it back and whatever, right? So it kind of depends. And don't look at me like that. I think I know what I'm not talking about. But yeah, so so it's terrible. And to give you an example, I didn't put it in here actually because I don't want anybody to like put a screenshot of my slides somewhere and say, hey, Java's terrible. But like the C++ version runs, this is like, it's a game from 2005, right? And it was highly optimized. It runs, I think, average like 128 megs of RAM, and if you like put the settings to ultra, super, duper, or whatever, I think it runs like 256 megabytes of RAM. The Java version runs, I think, an average of like 1 gigabyte of RAM, right? Hey, don't this is Java, but yeah. But again, this is not optimized. None of my Java code is optimized. So actually, most of the code is the opposite of optimized. Because the way I developed it, I tried to stay true to the C++ code. Because at certain points, actually at most points, I want to debug it, right? So if I optimize it and it no longer looks like this, like C++ version, it's kind of difficult to debug, right? But yeah, even if it's optimized, let's put it this way, it will never reach what C++ reached, right? It will never happen, right? But so what? People say memory is cheap, which it isn't, but whatever, right? How much time do I have?
Well, 10 minutes.
Excellent. I'm going to skip this because so these are things that, okay, so very quickly. So these are things, you don't have pointers, you don't have macros. I hate macros, but you don't have, they can be very useful. They are very useful in the gaming world, not in every C++ world actually. And you don't have operator overloading, which I really, really miss, right? I even wrote something for operator overloading, but that's a different story. But you have type safety, which I really love, right? And like I said, I'm going to skip this. I'm just mentioning it because I don't know why. So yeah, so this is the thing. I think one of you two guys asked about this before. It's kind of related to what you were talking about, right? So why use? So you use arrays instead of collections, right? Especially, right? STL is kind of like the Java util collection thing. It has much more, but it's kind of like that, right? And STL is like, it's an extension of C++ which has a lot of cool libraries, right? Am I saying this right? I'm looking at you because you know a lot of stuff. Am I saying this right about STL? It's a lot what, sorry? Yeah, but C++ doesn't care. Yeah, I mean, STL is, I don't know, is STL actually part of the standard? I don't know. It is? Okay, so it is, right? So, yeah, I honestly didn't know that, because back in the day, okay, so no, I have no idea. I always thought it wasn't part of the standard, right? I thought that because effective C++ has a separate book for STL, so I thought it was something separate, right? But if you don't know what effective C++ is, you know effective Java? That was actually stolen from something called effective C++. It's a different book, and whatever, doesn't matter, right? But STL has a lot of stuff, right? But Java has like a lot of better stuff, I think, right? Java has put a lot of thought into that, right? So it's cool. Intrinsic for the win, right? So you have a lot of Java functions. C++, if you have a function, gets compiled like it is, right? And the compiler does optimization for you. In Java, it's kind of different. If you open something, and I assume most of you know this actually, but if you open something and you see a piece of code and you copy that piece of code and you run a benchmark, it will be much slower than if you don't run it, right? If you run the actual call, right? Something in the, yeah. Anybody have any questions? I'm gonna.
Not directly related to this, but we are kind of running out of time, and I'm very curious, how did you approach the inverse square root calculation of the 3D?
Okay. So to repeat the question, because you're my friend, yeah. So because we're running out of time, he wanted to ask a question that's unrelated to this, but is how did I approach the inverse square root algorithm? Yeah, I don't know if it's an algorithm, but that part, right? And if you don't know the inverse square root, it was something nobody knows for sure who came up with it, but it speeds. Sorry?
Probably John Carter.
Yeah, he himself says he didn't come up with it, right? So from the MIT book. It's possible. I have no idea, but let's just assume we don't know. It's just some aliens, right? We don't care. But it's a very known algorithm, and it was written in C++, and it only works in C++ because in C or C++ actually because you kind of like directly talk to the registers, right? If you do it without that, yeah, then you talk to a VM which talks to the registers, which is what I do. To answer your question, like I said, debuggability is very important to me at this point, right? Optimization, performance, only if it kills me, then, right? If something takes like 7 minutes to load or whatever, I don't see you. So only if it takes like a very long time. So I had a problem with file IO, for example, right? Because I ported it the way fread does it and that kind of stuff, which was like the shittiest thing ever, right? And something was like loading in like 3 minutes, right? And in the C++ version it took like 2 seconds, right? So that part I rewrote in Java. I rewrote in a completely different way, right? But mostly I don't do optimization yet.
You use approximation.
What's approximation?
Just guessing the value near the point.
For the, you mean for the inverse square root?
That too, but in general.
Yeah, but the way Java implemented all that stuff is kind of it still holds kind of true, right? Yeah, it's not 100%. So yeah, it is kind of approximation, what you say. But the funny thing about this, if you approximate it everywhere, it still holds true, right? Because you're off by the same error everywhere, right? Let's not talk about this anymore. And, but any other questions? Because yes, sir. Do I have time to show them the demo?
We still have 5 minutes.
Is that including questions or excluding questions? Because I haven't had any questions yet, and I need time for that. So, okay, so I have 5 minutes yet. So I'm gonna, sorry?
You're supposed to
Yeah, okay. Okay, I'm gonna show you the demo. I'm gonna skip this. Cool stuff. Just look at it. Cool stuff. This isn't true, but cool stuff. This is true, right? So you don't have console support for Java, which is, I think, the biggest problem with game development, right? Because you don't have any native JVMs for most of the game consoles we know. But, and this is about, I don't say you should do this, but it's just cool, so I want to show you guys. Apparently, the Blu-ray specification has a part of Java in it. I did not know this. I just discovered it like a week ago, right? And this is somebody who made a video. He created like a small game in Java, and he ran it on the Xbox One and the PlayStation 4 through the Blu-ray, the part of Java that is in the Blu-ray specification. So unfortunately, it's a 6-minute video, so I'm not going to show. Maybe I'll show you like the part where it says it's Java. Okay, this didn't work. Okay, just trust me. It's cool. I don't know how to get this. No. Okay, that's. I should have thought about that. Anyways, it works. It's just amazing. Just search it on YouTube. You will find it, right? This is some cool stuff I wanted to mention, but yeah, because of the demo, the one thing. Just going to start up IntelliJ in the meantime. But the one thing I really want to mention is just there's a lot of untapped potential in Java, right? So a lot of things, a lot of problems that we might face in game development, and a lot of problems we do face in game development, are kind of easy to solve. And I don't mean easy in the sense, so that's why I said Rich Hick here, right? Because he has a whole talk who explains the difference between easy and simple, apparently. I don't mean easy in the sense that you can solve it in 5 minutes, but we already know what the solution is, right? But nobody does it. Nobody takes the time to actually do it, right? So yeah, there's a lot of stuff like that. I'm going to show you the demo, and I mean literally the demo. I hope this works. Yeah, it never works with 2 screens. In the meantime, questions? Just ask. Sorry? This is the demo. This is literally the demo. It took me some time actually to get the demo itself working, because apparently the demo was, in the olden days, they released the demo like months in advance, right? Nowadays they don't do that anymore. You can kind of hear the music. But the demo was made with different build of everything. Different build of the script, different build of like code or whatever, so I had to like do a lot of like exceptions in the demo. Shit. Yeah, don't comment about the mouse. I haven't captured it because it's easier this way. Questions? Remarks? Does anybody still like Java? Sorry. Sorry?
You mentioned it goes really fast, but it runs good in...
It runs pretty good, yeah. So the question is, yes, my friend. So how does it run, right? So I mentioned a lot about loading times and that kind of stuff. So how does it actually run? So my answer is you will kind of see it right now, but no, it runs pretty good, right? And one of the lightning talks, he mentioned something, I think it was about, no, I don't remember which talk, but he mentioned something about something was ported and they had to port it with errors, right? Because the same errors, right? This is actually funny because I had a similar thing. I have a specific level that I load, and it's just very slow at the beginning. And I thought, oh shit, man, I broke the game or whatever, right? But then I load the C++ version of the game, the same level. It's also very slow at the beginning. So I mimic the inefficiency, which is very important, right? Yeah, I'm just skipping this stuff because we don't have time, I think. Yeah, so this is the problem. Doom is a very dark game, right? And, no, I want the console. Yes. And I have to turn off shadows because that part is still broken. Yeah, so it's a very dark game. We don't have a light switch here. Do we have a light switch? In the olden days, they used to show it on wireframe, but I thought we were beyond that point. So, yeah, we can do this, I think? No. We can do this. We can cheat. We can always cheat, right? And the reason we're cheating is you get the flashlight. Okay, you don't get the flashlight. I don't know why I didn't get the flashlight. But yeah, this is really tiring. I must say, it actually looks better from here. So if you want to see it, you can see. Where am I? I'm probably over time, so if anybody has any questions or remarks, you can just tweet them at me. Don't tweet them at me. Send me a private message. Or just tweet them at me. Doesn't matter. How much time do I have? -2.
Less 3.
Excellent. Yeah, okay. So yeah, thank you very much.